Hello students, welcome to 60 out of 60 in KCET Chemistry 2025 series in just 200 days. So till now we have completed the most important chapter, that is aldehydes, ketones and carboxylic acid. So as after every organic chapter we do a revision class. So today is the complete revision of aldehydes, ketones and carboxylic acid. So we'll be revising all the methods of preparation and all the chemical reactions of these three topics. So I want all of you to sit with a notebook and a pen and make flowchart diagrams for all these reactions so that you can revise them very easily. Okay, so yes, one more request, please join our WhatsApp channel. The link of the WhatsApp channel will be there in the description section of this video, so you can go there and then you can just join the channel so that you can get access to all the PDF notes, you can get access to question papers, solutions, etc. Okay, so please join, do not forget. And now let's get started with our revision. Okay, very important lecture, and I'll also be giving you some 15 to 20 questions practice also, so that we can have a like brush up of all our concepts. Okay, so now let's get started without any delay. Okay, so today's class, what all things we are going to study? So today first of all we are going to do preparation of aldehydes and ketones. Next we'll be covering preparation of carboxylic acid, then chemical reactions of aldehydes and ketones, and then part 4 will be chemical reactions of carboxylic acids. Okay, so year wise weightage, as you all know, it carries almost around 3 to 4 questions. Okay, now coming to the first one, preparations of aldehydes and ketones. So preparation of aldehydes and ketones will be studying under 3 sections, where we'll be studying methods where both aldehydes and ketones can be prepared, next for only aldehydes, and then only for ketones. Okay, so now coming to this one is the lengthiest part and more reactions are there under this one. Now coming to preparation of both aldehydes and ketones. Okay, so here what all reactions we have? By oxidation of alcohols, by dehydration of alcohols, and from hydrocarbons. Okay, oxidation of alcohols, then we have dehydration of alcohols, and then by hydrocarbons. Now coming to for only aldehydes, we have from acyl chlorides, from nitriles and esters, and then from hydrocarbons. And then coming to preparation of ketones, again we have from acyl chlorides, from nitriles, and then from substituted benzene. Now coming to from hydrocarbons, here we have 2 categories, one is ozonolysis and then hydration of alkynes. Now coming to here from hydrocarbons, we have oxidation of methyl benzene, we have chlorination of side chain, and then we have Gattermann-Koch reaction. Clear? This is the complete methods of preparation of both aldehydes and ketones, and only methods of preparation of aldehydes and then preparation of ketone. Let us revise them once again. For both aldehydes and ketones, we have oxidation of alcohols, dehydration of alcohols, and then from hydrocarbons. Under hydrocarbons we have ozonolysis and from hydration of ethynes. Okay, next coming to preparation of only ketones, preparation of only aldehydes. Here again we have 3 methods. First is from your acid chlorides, second is from nitriles and esters, and then third one is from hydrocarbons. Under this we have 3 categories. The first one is from oxidation of methyl benzene, chlorination of side chain, and then you have Gattermann-Koch reaction. Next coming to preparation of only ketones, here we have first one is from your acyl chlorides, then you have from nitriles, and then from substituted benzenes. Okay, so now let's start with these reactions. Okay, so preparation of aldehydes and ketones, okay, where both the methods are there. As I told you, first one is by oxidation of alcohols, by dehydration of alcohols, and then from hydrocarbons. Okay, under hydrocarbons we have ozonolysis and hydration of alkynes. Okay, so now we will see the reaction. So the first one here is from the oxidation of alcohols, right? The first method is oxidation of alcohols. Okay, so now if you see under oxidation of alcohols, we have both primary alcohols and secondary alcohols. So primary alcohols will give you aldehydes and secondary alcohols will give you ketones. Please remember this one. Primary alcohols will give you aldehydes, secondary alcohols will give you ketones, right? Now coming to reagent. So the reagent required here will be your PCC or chromium oxide. Okay, PCC or CrO3. So the primary alcohols will give you aldehydes, secondary alcohols will give you ketones. First method from alcohols, or you can say from oxidation of alcohols. Now the second method here is from dehydration of alcohols, right? From dehydration of alcohols. Here also you should remember primary alcohols and secondary alcohols. So primary alcohols will give you aldehydes and secondary alcohols will give you ketones. Rehydration reagent uses copper at 573 Kelvin. Okay. Next, third one is from hydrocarbons. So the third one is from hydrocarbons. Okay, and in this the first one we have 3A is ozonolysis. Okay, so in under ozonolysis, so this reagent used or the reaction used here is O3, reagent used is O3Zn water. Okay, O3 in presence of Zn and water. Now here what happens, when you treat with this one, this bond breaks. Okay, and we have attach a double bond here and attach oxygen on both sides. Now for example, if you have CH3 CH double bond CH2 and then you treat it with O3 Zn water, then what you will observe that this bond breaks here. Okay, you have to attach one oxygen here and one oxygen here. So I will get here CH3 C double bond O H plus here it is C double bond O H2, right? So this is what ethanol and this is methanol. Okay, we'll get two compounds. So that is how ozonolysis takes place. The 3B, the next one method is from hydration of alkynes. Hydration of alkynes. So here what happens, first of all you add water in presence of H plus and Hg2 plus, addition of water in presence of H plus and Hg2 plus. Now what happens here, this one, this addition of H and OH takes place following Markovnikov's rule. Okay, following Markovnikov's rule. After that there is something called as tautomerization and we get aldehydes or ketones. So we'll do this with an example. So let us take here propine, suppose. Okay, so first of all what we'll do, we'll add H plus we'll add water in presence of H plus or H and Hg2 plus. So OH and H will be added following Markovnikov's rule. So I'll get CH3 C OH double bond CH2, right? Now here what happens, tautomerization takes place. Okay, so this one will come here and this bond comes here and we get a compound like this, CH3 C double bond O CH3. Okay, so this is how the addition of hydration of alkynes can give you aldehydes or ketones. So here some points that you can remember is if you take any alkyne here, generally you will get ketones. Okay, and if you take for ethyne, okay, then also in case of ethyne you will get aldehydes. Okay, so if you take ethyne, then you will get aldehydes, and with all other alkynes you will get ketones. Okay, so this point you can remember. So we have done all the three methods. So the first one is oxidation of alcohols. Second one, reagent required here is PCC or chromium oxide. Second one, reduction of your alcohols. So here the reagent required is copper at 573 Kelvin. Third one, from hydrocarbons. Here we have two sections. First one, ozonolysis. Reagent used is O3 Zn water, and the 3B is from your ethynes or you can say alkynes, addition of water in presence of H plus and Hg2 plus, that is followed by tautomerization to give you the aldehydes or ketones. Clear? Next will come to the second one, that is preparation of only aldehydes. This is very important one. So in the preparation of only aldehydes, first one we have from acyl chlorides, second from nitriles and esters, third one from hydrocarbons. under hydrocarbons, okay, under nitriles we have again two reactions, Stephan reduction and using dibyl H. Then from hydrocarbons we have oxidation of methyl benzenes, chlorination of side chain and Gattermann-Koch reaction. So these all, so 1, 2, 3, 4, 5, 6. So almost 6 to 7 reactions we are going to revise in one particular slide, okay. So next, in under oxidation of methyl benzene you have Itard reaction and the use of chromium oxide, okay. So now let us see this one. Okay, so you can see this is very important flow chart. The first one method of preparation was from acyl chlorides. So we'll go to that first. So from acyl chlorides, the first one, okay, sorry, one second. Yeah, the first one here is from acyl chlorides. Okay, so now here what happens, what is the reagent to be used? H2 palladium barium sulfate. So this one will do what? This Cl is replaced with H. Okay, this, so we will get benzaldehyde, C double bond O, H will come here. Now this reaction particular has a name reaction and this is called as Rosenmond reaction. Rosenmond reaction. Rosenmond reaction. Okay, I hope all of you can see. The first one is from acyl chlorides. You have to take any COCl, just treat it with H2 palladium barium sulfate. This Cl group is replaced with H. Okay, and the name of this reaction is Rosenmond reaction. Okay, from acyl chlorides. The second one we had is from nitriles and esters. So you can see here we have the first one, that is from nitriles. Okay, from nitriles. Okay, so now from nitriles you can see there are two reactions we can do to get aldehydes and ketones. So sorry, to get aldehydes. So first one, if you take nitriles and treat it with SN2 and HCl, okay, that is happening reduction here. So what will happen, you have to add both H to this and one bond will break and one H will be added on both sides. So you'll get RCH and NH. This compound formed here is called as imines. Okay, after that if you do hydrolysis we will get RCHO. Okay, so this bond will break, here oxygen will come and this part will go. Now this particular reaction where you have to first treat it with SnCl2 HCl and then you have to do hydrolysis H3O plus, this particular name reaction is there and this is called as Stephan reduction, or you can just say Stephan reaction. Clear? So from nitriles, so that is your second method. See, from nitriles, okay, the first one is Stephan reaction. Now from nitriles you can directly come to RCHO by using another reagent that is called as dibyl H, diisobutyl aluminium hydride. Okay, so ALH, IBU2 and water. If you use this one, this is your second method. From RCN, by using dibyl H and water we can get RCHO. Okay, now coming to another, from esters also you can use dibyl H and water. So this is from esters. From esters, so if you use dibyl H and water, what will happen, this one will break, here just one H will be added. Similarly, if you, in case of nitration, what will happen, nitriles, what will happen, this bond will break, C double bond O, H will come. Okay, so this is your from nitriles and esters. Now the third one is from hydrocarbons. Under that we had three categories, right? So first, now we'll go to the third one, from hydrocarbons. Okay, under hydrocarbons we have the first one, that is your Itard reaction. So under Itard reaction what happens, we take methyl benzenes. Okay, so under methyl benzene you just treat it with CrO2 and Cl2. So we'll get a complex like this, CH, OCrOH Cl2 whole 2. So this is your chromium complex. Okay, and then you treat it with H3O plus and we will get RCHO. Okay, so this is the first method. Next you can do another reaction where you take the same methyl benzenes, okay, and treat it with chromium oxide and CH3CO whole 2. So this is your from hydrocarbons, the first one I can write it 1A, and this is So next one is your 1B. Again you just take methyl benzene, chromium oxide, CH3CO whole 2O, and this one will give you OCO CH3 complex, and just treat it with H3O plus to give you RCHO. Okay, so remember, under from hydrocarbons we have first from methyl benzenes. Under methyl benzenes we have one is Itard reaction, where you have to use CrO2Cl2, okay, and in presence of CS2 then you get a chromium complex, and then you have to do hydrolysis. Another one is you have to take methyl benzene and treat it with CrO3 in presence of acetic anhydride. So you will get CHOCO CH3 whole 2, and then just do hydrolysis to give you RCHO. This is done. Okay, next coming to the second, we have done 3. Okay, next one we have is your again from chlorination of side chain. Okay, so chlorination of side chain. So here what happens, when you treat it with chlorine H nu, we get CHCl2 Cl2. Okay, then when you treat it with water, it becomes CHOH, right? After that, on one carbon 2 OH group is not stable, so there will be dehydration and we'll get RCHO. Okay, and the next one is from benzenes, the name reaction, that is your Gattermann-Koch reaction. Gattermann-Koch reaction. So here you have to take simply benzene in presence of COHCl, anhydrous AlCl3 or copper chloride. Okay, and this one will give you benzaldehyde. Clear? So I hope all the name reactions are clear. What we can do is now we can revise using this slide. Okay, so first of all, if you remember, from acyl chloride, what was the reagent? H2 palladium barium sulfate, right? H2 palladium barium sulfate. And what was the name of this reaction? The name of this reaction was Rosenmond reaction. Right? I hope all of you have revised this one. Now coming to from nitriles and esters. So from nitriles and esters, if you use Stephan reduction, then what was the process? We have to use SnCl2 in presence of HCl. Okay, then we used to get imines, and after we get, so this one will give me imines, right? So after imines, if I do hydrolysis H3O plus, so this one will give me RCHO. Or we can simply use dibyl H with both RCN and esters, that is RCOOR dash. Okay. Next coming to from hydrocarbons, under hydrocarbons we have oxidation of methyl benzene. The first one was Itard reaction. What is the reagent required here? CrO2Cl2 in presence of CS2. After that we used to get a chromium complex, right? And after that, if I do hydrolysis, I used to get aldehydes, right? So we have to do after this hydrolysis to get aldehydes, right? Use of chromium oxide also you can do. You can just take methyl benzene in presence of chromium oxide and acetic anhydride, CH3CO whole 2O. This will give you a complex. After that, if you do hydrolysis, again we will get aldehydes. Okay. Next coming to chlorination of side chain. So here first of all you have to do Cl2 and H nu, then we'll get 2 chlorine will be there, then you just treat it with aqueous NaOH, right? You can treat it with H2O, you can treat it with NaOH, water, whichever can give you OH group, then that will give you one second, yeah. So OH will come, then dehydration will take place, and then we can get aldehydes. Next coming to Gattermann-Koch reaction, the reagent used is COHCl in presence of anhydrous AlCl3 and CuCl, right? So this one will give you aldehyde. Okay, fine. Next coming to preparation of only ketones. Okay, so in preparation of only ketones we have first one from acyl chlorides, next we have from nitriles, and then we have from substituted benzene. Okay, acyl chlorides, nitriles, and from substituted benzene. So let us see this reaction now. So first one is from acyl chlorides. The first one is using or from acyl chlorides. So here you use dialkyl cadmium. Okay, so if you use RCOCl with R2CD, okay, so this is dialkyl cadmium, and this one R will replace this Cl and will get RCOR. Okay, so just I'll write it like R dash this one, so we'll get R dash COR. The first one from your, which is this one, from acyl chlorides. Okay, the second one was from nitriles, right? 2 was from nitriles. RCN is there. Now if you treat it with RMGBr, so now if you see, this is plus, this is minus, and this is minus, and this is plus, right? So what you have to do, C will take minus, minus will take plus, so one bond will break, okay, and then here C6H5 will attach, and here NMGBr will attach. Then you can just do hydrolysis, this bond will break, and we will get CO here. Clear? And next, the third one was from substituted benzenes or from benzenes. So from benzenes, this reaction RCOCl in presence of AlCl3, all of you must remember this one. This is your Friedel-Crafts acylation, right? So with preparation, with this we can prepare your ketones. Okay, so 3 method clear. So let us revise here. With from acyl chlorides we need R2 cadmium. Okay, then from nitriles we need RMGX, and then with this one we need RCOCl in presence of AlCl3. Okay, so these are the 3 reactions with which we can prepare ketones. Okay, now we'll go to preparations of carboxylic acid, methods of preparation of carboxylic acid. So the first one is from alcohols and aldehydes, second one from alkyl benzenes, third one from nitriles or amides, then fourth one from Grignard reagent, fifth one from acyl halides and anhydrides, and the sixth one is from esters. So there are 6 methods. Let us revise them again. The first one is from primary alcohols or aldehydes. Okay, second one we have from alkyl benzenes, third we have from nitriles and amides, fourth we are having from Grignard reagent, fifth from acyl halides and anhydrides, and last one is from esters. Okay, once again let us tell. First one is from primary alcohols and aldehydes, second one is from alkyl benzenes, third one from nitriles and amides, fourth one using Grignard reagent, fifth one from acyl halides or anhydrides, and the last one is from esters. So now coming to the reactions here. So as I told you, the first one was from primary alcohols and aldehydes. Okay, so we will start with that first. So here we have primary alcohols. So first one from primary alcohols. So if you remember, we have discussed that primary alcohols under strong oxidation can give you carboxylic acid. Primary alcohols under strong oxidation can give you carboxylic acid. Now what is the reagent for this strong oxidation? So for strong oxidation we need alkaline KMnO4. Okay, we can use alkaline KMnO4, or you can use CrO3H2SO4. Now this is called as your Jones reagent. Okay, so the first method was from primary alcohols. So you can use strong oxidizing agents like KMnO4, K2Cr2O7 or Jones reagent and can get your acid. Okay, so the second method of preparation was from alkyl benzenes, right? So the second one was from alkyl benzenes. So here you can take any alkyl group. Okay, this is R, any alkyl group, just treat it with alkaline KMnO4 and then heat H3O plus. This R group will get converted to RCOOH, or benzene COOH. So here it need not be that only one carbon is required. You can take 2 carbon, 3 carbon, 4 carbon, anything will get converted to carboxylic acid. Okay, so the second method is from alkyl benzenes. Clear? Reagent is same. The third one is from nitriles and amides. Third one is from nitriles and amides. So here we have RCN. Okay, So now if you just treat it with H plus or OH minus, this one gets converted to RCONH2, which is your amides. Okay, then you do H3O plus, that is your acid hydrolysis. This will give you RCOOH. Okay, so RCN will get converted to RCONH2 amides. Amides on hydrolysis will give you acids. Okay, so the third method is from your amides or nitriles. Next, fourth one is using Grignard reagent. Okay, so the fourth one is from Grignard reagent. So here Grignard reagent is treated with carbon dioxide. Okay, so if you see now, this is R minus, this is Mg plus, and we have carbon plus, oxygen minus. So what will happen? This one will attack here and this one will attack here. So we will get here, now see, O, we have this one with O, Mgx is there, and one side there is R, right? So now what will happen? There will be hydrolysis, you will get again carboxylic acid. Okay. Next, the fifth one was from acyl chlorides. From acyl chlorides. So RCOCl. Okay. So here you can do it in two way. RCOCl, directly you treat it with water, we will get this acids, or you can first treat it with OH minus, you will get ORCO minus a salt, and then do hydrolysis, will get RCOH. Okay, that is from acyl chlorides. And we have from esters. So esters, simply treat it with water. What will happen? This bond will break. You will get one this side. You will get one acid, and this side you will get another acid. Okay, so this way we can prepare from esters. Okay. Now coming to another, this is anhydride, from anhydrides. Okay, from anhydrides we will get. Next, from esters also we can get. Okay, from esters, so this bond you can just break it and you will get again your carboxylic acid. Okay, so we have 6 methods of preparation. First one is from your primary alcohols. The reagent required here is any strong oxidizing agent. Second one we have from alkyl benzene, again strong oxidizing agent. Third one we have from nitriles or amides, here you have to do hydrolysis. Fourth one we have from Grignard reagent, you have to treat it with carbon dioxide. Then fifth one we have from your acyl chlorides and anhydrides. So here also you have to treat it with water. Then you have from esters, and esters also your hydrolysis will give you carboxylic acid. Okay. So next, coming to the next method of preparation. Okay, so all the 3 methods of preparation we have completed. Carboxylic acid, both aldehydes and ketones, only aldehydes, only ketones. Now we will go to study their chemical reactions. Okay, so starting with the chemical reactions of aldehydes and ketones. Okay, so the first one is nucleophilic addition reaction, then we have reduction reaction, oxidation reaction, then you have reactions due to alpha hydrogen and other reactions. Okay, under nucleophilic reactions or additions, we have 5 reactions: addition of HCN, addition of NaHSO3, addition of Grignard reagent, addition of alcohols, and addition of ammonia and its derivatives. Under reduction, we have reductions to alcohols and reductions to hydrocarbons. Okay. Next, under oxidation, we have tolerance test, Fehling test, and oxidation of methyl ketones. Next, reactions due to alpha hydrogen, we have aldol condensation and cross aldol condensation. Next, in other reactions, we have Cannizzaro reaction and electrophilic substitution reaction. Okay, a big table is there, a lot of reactions are there, but believe me, if you practice it again and again, you will easily remember it. So let us revise it once again. Reactions of aldehydes and ketones. The first one is nucleophilic addition reaction. Under that we have 5 reactions: addition of HCN, addition of NaHSO3, then you have addition of alcohols, then you have addition of Grignard reagent, and fifth one is addition of ammonia and its derivatives. Okay. Now second reaction is reduction. Here we have 2 categories: reductions to alcohols and reductions to hydrocarbons. Next, third one we have oxidation. Here again we have 3 reagents: tolerance test, Fehling test, and oxidation of methyl ketones. Next, fourth one is reactions due to alpha hydrogen. Here we have 2 reactions. The first one is your aldol condensation and the next one is cross aldol condensation. And the miscellaneous or other reactions, under that we have 2 reactions: Cannizzaro reactions and electrophilic substitution reaction. Okay. So now let us start with the first reactions, that is reaction or the nucleophilic addition reaction. Okay, so if you see under nucleophilic addition reaction, we have, as I told you, 5 addition reactions: addition of HCN, addition of NaHSO3, addition of Grignard reagent, addition of alcohols, and addition of ammonia and its derivative. Now, and before undergoing and understanding these 5 reactions of the nucleophilic addition reaction, first let us understand the basics of this nucleophilic addition reaction. Now see, this is any carbonyl compound and this is a nucleophile. As we have discussed, this is delta minus, this is delta plus. So this carbon is what? Electrophilic in nature, right? So obviously this nucleophile will attack on this carbon, this bond will shift here, right? So what we will get? C, then I'll get Nu here, and this O minus will get hydrolysis to give you OH. Clear? This is the general mechanism. Now let us start with this 5 nucleophilic addition reactions. So the first one was addition of HCN, right? So let us start with the first one. The first one, addition of HCN. So here what is the nucleophile? Cn minus, right? So this Cn minus will attack on this carbon, this bond will shift here. So we will get Cn and OH attached to the carbon, addition of HCN. Next, second one is addition of NaHSO3. So here how the bond breaks? Na plus and HSO3 minus. So what will happen? O minus will take your Na plus, okay, O minus takes Na plus, and the C plus take HSO3 minus, this part. Then there is what happening? Proton transfer. This H goes here and this Na plus comes here. So we get OH and OSO2 Na. Okay. Next, third one is addition of Grignard reagent. So here what happens? Mg plus is minus and R is Mgx and R minus. So again this bond, this is minus, this is plus. So C will take R, O will take Mgx, and then there will be hydrolysis. This OMgx gets converted to OH, right? So this is your third one, addition of Grignard reagent. Fourth one is addition of alcohols. So here what will happen? This alcohols will give you H plus and O minus. So RO minus will attack here and we will get OH here, right? So we will get OR and OH. Now if you, this particular is called as your hemiacetal. Okay, hemiacetal. Now after you further add one more molecule of alcohols, okay, this OH gets converted to OR and this is called as acetal. Okay, so we have fourth one here. Next, fifth one is addition of ammonia and its derivatives. So this is very, very important reaction. Many questions have been asked from this particular segment. So here what happens, if you have any carbonyl group, okay, and you have ammonia and its derivative, this is, if this Z is equal to H, then it is ammonia, otherwise it is derivative of ammonia. Now what happens here, there is removal of this water. So we will get double bond N and Z. Okay, so that is what you can see here. We'll get this as the final product. Clear? But with ammonia and its derivative, we have a lot of reactions. So we'll see now around 7 reactions are there. So now let us see the reactions of ammonia and its derivative. So first one, as I told you, this is your structure, right? H2 and Z. Okay, so wait one second. Yeah, you have H2, N and Z. This Z will change. Okay, this Z will change, and what is our product? If you remember, I told you C double bond O plus H2NZ. If you have this, H2O will go, so I'll get C double bond O and Z, right? So this Z will vary. So now if Z is equal to H, okay, then this is called as ammonia and we'll get C double bond N. So this Z will be replaced with H and this is called as imine. Now if you have R, okay, so Z will be replaced with R and we'll got a substituted imine. Then if you have OH, then we call it hydroxylamine. This Z will give you OH and the product formed here is called as oxime. Next, if you have NH2, this is called hydrazine. This Z is replaced with NH2 and we will get hydrazone. Next, if you have here phenylhydrazine, we'll get phenylhydrazone. Next, you have 2,4-DNP dinitrophenylhydrazine. So this is there. This will give you 2,4-dinitrophenylhydrazone. Then if you have NHCONH2 semicarbazide, then this one will give you semicarbazone. Okay, this is your Z. This part is Z, again this part is Z, then you have this as Z here, right? Okay, So next coming to reduction reactions. So under reduction again we have two types of reduction reaction. One is reductions to alcohols and another is reductions to hydrocarbons. Okay. So under reductions to hydrocarbons we have two reactions, Wolff-Kishner and Clemmensen reduction. Okay. So now coming to see their reactions. So first one is your reductions to alcohols. The first one was reductions to alcohols. Reduction to alcohols. So here what is the reagent required? Here the reagent required is LiLH4 or NaBH4. Sorry, LiLH4 or NaBH4 you can use. Next coming to reductions to hydrocarbons. Under that we have two reactions. First one is ZnHgHCl and this reaction is called as Clemmensen reduction. Clemmensen reduction. Okay. ZnHgHCl. So here this double bond O is replaced with CH2. Next, if you have this one, if you treat it with NH2, NH2, so first this is a formation of hydrazone. After that KOH and ethylene glycol, this one will get converted to CH. So this reaction is called as Wolff-Kishner reduction. Wolff-Kishner reduction, right? So we will get two reactions where there is reductions to hydrocarbons and this is the reagent for reductions to alcohols. Okay. So next coming to next reaction is oxidation. Okay. So under oxidation we have first one tolerance test, Felling's test and oxidation of methyl ketones. Okay. So here I want to tell one thing, that if you take any alcohols, any aldehydes, okay, and you just oxidize them, we will get acids group. Okay. Now if you take any ketone group, for example if I have CH3, CH2, C double bond O and then CH3. Okay. So just let me number this carbon 1, 2, 3. Okay. So now if I do oxidation here, okay, so you will get a mixture of products here. Now what is there? Suppose oxidation is happening. First there is a possibility that this bond will break. So if this bond breaks, so we'll get one acid this side and one acid of this side. So what I'll get? CH3, CH2 and then we have COOH plus this one carbon acid is HCOOH. Next there's another possibility, this one if 2 carbon breaks, there's another possibility if 2-3 bond breaks, that is this bond is breaking. In that case what will happen? We'll get one acid here and one acid here. So this is an acid of 2 carbons, so I'll get CH3, COOH and this is also an acid of 2 carbons, so I'll get CH3, COOH. So when ketones undergo oxidation we get a mixture of products, okay, and when aldehydes undergo oxidation we get acids. Okay. So now here we have different reagents for oxidations of aldehydes. Okay. So here let us see. So the first one here RCOH with this reagent Ag silver ammonia, okay, or ammonium silver. So this is called as your Tollens test. Okay, Tollens test or reagent. So this one will give you RCO minus Ag plus ammonia plus water. Okay. So what we will observe? We will observe a silver mirror, silver lining in the glass tube. Next, if you there your Felling's reagent, right? So for Felling's reagent, this is your Felling's test. Okay, Felling's test you need to take copper oxide. Copper is formed copper 2 plus in presence of 5 OH. So this one is from copper oxide, which is a red precipitate. Okay, so by this you can observe the changes. So aldehydes can give you Tollens test and can give you Felling's test. But with Felling's test there is a thing that you should remember, that aromatic aldehydes do not give Felling's test. Okay, this is important and must be remembered. Then as I told you, the aldehydes undergo oxidation to give you acids. Okay. Next we have one more, second one is this one. Third one is oxidation of methyl ketones. Okay, oxidation of methyl ketones. Okay, so here what happens, this group our COCH3, this is called as methyl ketone. Now if you treat it with NaOX, okay, NaOX if you treat, or any like NaOI, NaOCl, then what happens, this part gets converted to acid and this part gets converted to CHX3. Okay, so whenever there is a presence of methyl ketone, this bond breaks, CH3 gets converted to CHX3 and this one we get converted to a salt. Okay, salt formation takes place. Now if this X is equal to I, okay, then we call it iodoform reaction. Iodoform reaction, and this this CHX3 is yellow in color if it is iodine. Okay, so by that we can differentiate the reactions. Okay, so under oxidation we have Tollens reagent, we have Fellings reagent, and then we have oxidation of methyl ketones. Okay, so third category of reaction is over. Next, coming to fourth one, that is reactions due to alpha hydrogen. Now first let us understand what is an alpha hydrogen. Suppose this is there, CH3 C double bond OH. Okay, so this is your alpha carbon and this hydrogen is alpha hydrogen, right? Now what happens with this alpha hydrogen, if it is present, then aldol condensation reaction can take place. Now just let us understand the mechanism of aldol condensation. So now you see, this is CH3COH. Okay, this reaction takes place in presence of dilute NaOH. Okay, so what will this OH minus do? Abstract one hydrogen from here, so we will get CH2 minus COH. Okay, next what you can do, you can take another molecule of this one, that is CH3COH. Now what will happen, this minus will attack here, CH3 will attack here, and this bond will shift like this. So what I will get, we will have CH3CO minus, then this carbon is having H, and then this CH2 group is attached to this one, CH2COH. Okay, so now after that, if you heat it, okay, if you heat it, what we will get, okay, let me write like this, CH2 and H. Suppose if I write like this OH will undergo, will be removed, and we will get here CH2 double bond CH, CH2, CHO. Okay, so this is a product, this is your, so we will get, okay, sorry, one second, there is two possibilities, right? Here also there is one H, okay, sorry, here also there is one H, so here also there is one H. So there can be a removal of OH from any of these two, but what will happen, we have to follow here Sedzeff rule. Okay, so if Sedzeff rule follows, then this OH will be removed and we'll get a double bond here. So I'll get CH3 CH double bond CH, and then I'll get COH, right? So now this is alpha and this is beta. So this compound is called as alpha beta unsaturated aldehydes. Okay, now coming to next one, how to do it, ma'am, do we have to do this mechanism every time we see the question? So here is a trick how you can do the products very easily. So now see, suppose I am having this one CH3COH. Okay, so I'll write here, this is the trick how to write the products. Okay, so next compound you have to write another molecule just below it, CH3COH. Now this is your alpha carbon, right? What you have to connect, what you have to do is you have to connect this alpha carbon to the carbonyl carbon. You have to connect the alpha carbon to the carbonyl carbon, and then you have to remove one hydrogen from here, make it H2, and add this hydrogen here. Okay, so now if I write, so 1, 2, 3 and 4. Okay, so we'll write first one COH, right? First carbon COH, second carbon we have CH2, third carbon we have CHOH, and fourth carbon we have CH3. Okay, so now again there will be dehydration. So as you know, this one will be more substituted alkene and more stable alkene. So what will happen, there will be a double bond here and we can make it CH. Okay, so this one will give you alpha beta unsaturated compounds. Okay, alpha beta unsaturated aldehydes. Okay, so this is the trick that you can remember to get the products quickly. Okay, what you have to do, you have to write the two aldehydes vertically, then connect one aldehyde, the alpha carbon, to the carbonyl carbon, then join it, remove one hydrogen from here, add one hydrogen here, and then just write down the product. Okay, fine. Next, coming to cross aldol condensation. So under cross aldol condensation, what happens? Two different types of aldehydes react. Okay, as you see here, two same aldehydes are reacting. In cross aldol condensation, two different types of aldehydes will react. So now let us see one example of like this. Suppose I have the same CH3COH plus I'll make it CH3COCH3. Okay, so now you see this is having alpha hydrogen, this is also alpha hydrogen. So now what happens? Suppose let me number this one as A and this one as B. Okay, so now we will get 4 products in case of cross aldol condensation. How I'll get 4 products? So first one, if A and A is reacting. Second one, if B plus B is reacting. Next, if A plus B is reacting and B plus A is reacting. So this will give you 4 different products. So the first one we have already discussed, right? CH3CHO, how it is reacting. Just now we have written the products. So I will write first this one, A plus A. So let me note down here. Yeah, if I have A plus A, okay, then what is the product formed here? We will get CH3 CH double bond CH CHO, right? This is the first product we'll get if A plus A is reacting. Now let us write B plus B. Okay, so I told you how to write the products, the trick. So now we'll assume B plus B. Okay, so B plus B is what? You have 2 CH3 C double bond O CH3. After that, what is the trick I told you? I'll write here CH3 C double bond O CH3. Next, this is alpha carbon, this is the carbonyl carbon, connect it, this bond will shift here, right? So after that we have to remove the hydrogen, right? So this will become H2 and here one hydrogen will come. So now let me number the carbon, 1, okay, 1, 2, okay, after this, this is 3, this is 4, this is 5, okay. So you have to write it in that way. And between 2 and 3 we will get the double bond, okay. So let me write first one, 1 is CH3, okay. Then I have 2 where I have OH. Then with this 2 carbon, this CH3 group is also attached, right? Then I have 3, that is your CH2. Then I have 4 CO and then I have CH3. Now here what happens? There will be, that is your dehydration and I'll get a double bond here, right? So this is my B plus B. So let us write down the products here. B plus B. B plus B. So what will this give you? Yeah, so this one will give you CH3, CH3, double bond, then I have CH, CO and CH3. Okay, now let us do A plus B. Okay, A plus B. So what is A here? We have CH3, COH and I have CH3, CO, CH3. So here what will happen? Again, this is alpha carbon, this is this carbon. So here you can just connect this one to this one, right? Then next step is to reduce the number of hydrogen. This will become H and this will become OH. Now just number them 1, 2. So this is not in the chain, right? So this will not be 2. So we have to go according to the chain. So this is 1. After this one, this is 2, this is 3 and this is 4. So let us draw this one. First one I have here C, here one CH3 is there, this CH3 is there, then I have OH. Okay, so next to this carbon it is CH2. Okay, then we have C double bond O and then I have CH3. So here this OH can undergo hydration, right? So we will get an alkene here, right? So this will be the product for this one. Let me write down here. So that is your A plus B. A plus B will give you, what is the product for A plus B? We have CH3, CH double bond, CH, CO, CH3. Okay. And now we will write the last product, that is B plus A. Okay, so B plus A will be what? Again we will apply the trick here, CH3COCH3, and I will write CH3COH here. So what will happen here? There will be connection. This will become H2, this will become OH, right? Now we can write the chain. This is 1, this is 2, this is 3, this is 4, this is 4 carbon. So let us write down here B plus A product. First I will write CH3, right? Then this one COH and this is CH2, so double bond will come here. So we have one CH3 to this carbon, then a double bond, and then I will have CH, and next I have COH, right? So these are the different products you can find by cross aldol condensation, right? Using trick you can easily solve this question. Okay. Next we'll come to the other reactions, or which I say the miscellaneous reactions. Under that first one we have Cannizzaro reaction. So here the condition you should remember is no alpha hydrogen and the reagent is concentrated NaOH. Okay. So for example, if you take benzaldehyde, right? So here there is no alpha hydrogen, right? Now what is the product here? We will get one acid salt, okay, and one alcohol. These are the products. So here what will happen? You will take concentrated NaOH. So here we will get C double bond O, O minus Na plus, that is your acid salt, and then we will get one more, that is alcohol, CH2OH. Okay. Similarly, we can have one more product here. Like suppose, let me take the example of formaldehyde, HCOH, right? Here also there is no, you can say there is no alpha hydrogen. So if you treat it with concentrated NaOH, so here we will get carboxylic acid, that is HC double bond O, O minus Na plus, plus we have here primary alcohol, that is HCH2OH. Okay, so that is how Cannizzaro reaction where there is no alpha hydrogen will get. Okay, next coming to electrophilic substitution reaction. So here if you remember one more important thing, whether it is CHO, this group is electron withdrawing group. Okay, so it will have meta directing group. Okay, so now if I treat it with, now suppose for example concentrated HNO3 and concentrated H2SO4. Now if you remember, this reagent is for nitration, so we will get here CHO, and at the meta position I will get NO2. Okay, the meta position we will get NO2. Similarly, suppose if you want to treat it with halogenation, that is Br2 in presence of FeBr3, right? So here also bromine will be added, but in the meta position. So we will get CHO Br2 in the meta position. Okay. Now suppose you want to add Friedel-Crafts acylation, that is CH3Cl alkylation, AlCl3. So what will this do? This will add CH3 group in the meta position. Right. So these are the different electrophilic substitution reactions that you can do in the case of benzaldehyde. Okay. So this, the thing that you have to remember is it is meta directing group. Okay. So with this we have done with the reactions of aldehydes and ketones, but it's not yet over. We have the last part, that is reactions of carboxylic acid. Okay. So under that first we have the reactions where there is cleavage of OH bond, then we have the reactions where there is cleavage of CO bond, then reactions where the whole COH group is involved, and the reactions involving hydrocarbon part. Okay. So now if you see under cleavage of OH bond, we have first discussed the acidic nature, and then we'll talk about reactions with metals and alkalis. Next, in the cleavage of CO bond, here we have reactions like anhydride formation, esterification, reactions with PCl5, PCl3 and SoCl2, and reaction with ammonia. Next, under reactions involving this whole COH group, here we have reduction and decarboxylation. Next, reactions involving hydrocarbon part, here we have halogenation and substitution. Okay, so again a lot many reactions have come for carboxylic acid, but yes, these are very easy reactions. So let us start with the first one, that is cleavage of OH bond. So here first thing that we'll talk about is the acidic nature. Okay, so now see, first thing we are talking about is acidic nature, another second thing is reactions with metals and alkalis. Now for acidic nature you should remember these 3 points. More acidic, so your carboxylic acids are more acidic than phenols. Okay, next, the electron withdrawing group increase the acidity. What is the order of the electron withdrawing group? First is CF3, NO2, then CN, then fluorine, chlorine, bromine, iodine and phenyl group. So we'll see one order of acids here. Okay, this is very important. The first one is CF3. So you can see CF3 is the first one. Then you have CCl3. Okay, next you have two, so there are two halogen groups here, 3 halogen groups. Next you have 2 halogen groups, CHCl2. After that you have NO2 group. Next you have CN group, right? After NO2 there is CN. Then you have normal fluorine group, chlorine group, bromine group, fluorine, chlorine, bromine. Okay, after that you see there is no group here. Okay, HCOH. After that you see Cl is there, but this is first, second, third carbon Cl is there. Here there is the phenyl group. Then you have again phenyl group. Here you have CH3COH group and CH3CH2COH group. Okay, this is the acidic order. Now if you see, so you do not have to remember this order, but you just need to know that if there is electron withdrawing groups, the acidity will increase. Now coming to reactions with metals, so here we have 3 types of reaction. One is reaction with Na. So this O minus Na plus will form with the production of H2 gas. If there is NaOH, so O minus Na plus and this H and this OH will give you water. And then NaHCO3 is there, then you will get again sodium salt plus H2O plus CO2. Clear? So these are normal reactions of metals with acids we have studied in class 10th also, so very easy reactions. So next coming to reactions where there is cleavage of CO bond. Here we have 4 reactions, right? First one is your esterification, then we have reaction with PCl5, PCl3, SOCl2, then we have ammonia and its derivative reaction. Okay, so let us quickly see them. Okay, so first one is your anhydride formation, esterification, reactions with PCl5, PCl3 and SOCl2, and the last one is reaction with ammonia. So let us see these quick reactions. Okay, so first one here is your anhydride formation. The first reaction here is anhydride formation. So this is 2 acids. Okay, you take any dehydrating agents like H plus heat or P2O5 heat, then what will happen? There will be dehydration. So this water group will be removed. So we have CH3, C double bond O, then oxygen, then CO, CH3, CH3, CO, O, CO, CH3. This is what? This is your anhydride. Okay. Now second reaction is your esterification. Okay. In esterification what happens? Again carboxylic group and alcohol group reacts. Now for carboxylic group the bond will break here. Remember, for acid OH this CO bond breaks, and for alcohol OH bond breaks, and here water is removed to give you RCOO, R dash plus H2O. Esterification. Okay. Next third one is reaction with PCl5, PCl3 and SOCl2. So in this case, this OH group is replaced with Cl. So you can see here, this is Cl, this is Cl and this is Cl. Byproducts are important for these 2 cases. PCl5 will give you a POCl3 plus water, PCl3 will give you H3PO3. Now SOCl2, this is SO2 gas and HCl gas is produced, right? This is your third reaction, that is reaction with PCl3, PCl5 and SOCl2. Okay. Now coming to the fourth one, that is reaction with ammonia and reactions of ammonia. So now what happens here? Ammonia acts as a base and this one is an acid, right? So O minus H plus will be produced. This H plus is taken by this ammonia. So we get a salt first, right? So this is a salt that is produced. Now how can we write? I'll write it in a different way to understand it in better way. See, CH3, C double bond O, O. This NH4 I'll write like this, H2NH2. Okay. In that case what will happen? This OH2 will be removed. Dehydration takes place. And then what is left? C double bond O NH2, that is your amides. Understood? So now we will practice 2 more questions with this one. Okay. So see. So you need to first do now these 2 questions. Okay. So first we'll get a salt of this one. So I'll write like this. I'll get this one. We'll get C double bond O, right? Then we have O here. This one will give you H2 and H2. Okay. After that, remove this one. So what will I get? We will get benzamide. Okay. Next, coming to this is very important one. So here first what happens? You will get this after this one. What we'll get? We will get C double bond O NH2 and we'll get C double bond O NH2, right? Now here what happens? There is a removal of ammonia. From this what happens? Removal of minus NH3. So you can see NH3. So there is what will be left here. We have 2N and 4H and you are removing 1N and 3H. So we are left with one more single N and 1 H. So this one will give you very important compound, that is C double bond O NH and C double bond O NH. This is called as phthalimide. Okay, phthalimide compound is formed here. Okay, this is important one. Please remember this one. Okay. So next we'll go to the next reactions where we have reactions of COOH group. Under that we have 2 reactions, reduction and decarboxylation, right? So reduction and decarboxylation. So reductions, you can see for reduction we require different reagents. For reduction of acids we can use LiLH4 or we can use ether with LiLH4 and ether, or you can use B2H6. Okay, this is OR. Do not use both, either this one or this one. So what will happen? This part will get converted to RCH2OH. Okay. Next, for decarboxylation we can use soda lime. Okay. So soda lime, if you know, NaOH, CO and heating, right? So this one will convert, it will remove this CO2 group. Okay. And here we will get H, RH plus Na2CO3. Okay. So that is what reactions involving COOH group. And the next 4th category of reaction is your reactions involving the hydrocarbon part. Okay. So here we have 2 reactions, halogenation and substitution. This is very important reaction, halogenation. Very, very important reaction. So here what happens? See, if first condition for this halogenation is presence of alpha hydrogen should be there. Okay. Now if you see, this is alpha carbon and this hydrogen is your alpha hydrogen, right? Now if you treat it with X2 red phosphorus and water, what will happen? This alpha hydrogen gets converted to X, right? Alpha hydrogen gets converted to X and X can be your chlorine or bromine. Okay. This is a name reaction and this reaction is called as Hell-Volhad-Zelinsky reaction. Zelinsky reaction, or in short we can tell it as HBZ reaction. Okay. And next one is substitution. So COH group also you should remember is a electron withdrawing group and that is why it is meta directing group. So if you do concentrated HNO3 and H2SO4, what is this one? This is nitration, right? So NO2 group is added at the meta position, right? Similarly, if you do Br2F, this is halogenation, right? Addition of halogen group. So again Br is added at the meta position, right? So these are the different reactions of your carboxylic acid. Under this HVZ reaction is very, very, very important. Please remember we need an alpha hydrogen for HVZ reaction. Okay. So we have revised the complete chapter. So nomenclature and all I have not used that much because that is something you know, I believe. But reactions are where the students face difficulty. So reactions revisions is need to be done again and again. So now we will do some practice questions. Okay. Okay, the first question here. So, okay, this question was the homework that I gave in the previous class. Let me see how many of you have answered it correctly. So, if you see here, KMnO4KOH, this will convert this to COOH, right? COH is a meta directing group, so bromine will be attacked at the meta position. So wherever bromine are there in the meta position, you can see only one option is there. So what is my A here? So A is here COOH will come. Okay, this whole group will be oxidized. Then bromine will come in the meta position. This is B now. Okay, now if you treat it with this one, so this is a carboxylic group, this is alcohols. Acids and alcohols react to give you esters. So what will I get here? We will get COO C2H5 and then we have Br. Okay, so COO C2H5 and Br. So correct answer for this question will be option number A. Okay. Okay, now let us do today's question. A compound A has the molecular formula of CCl3OH. It reduces Felling solution and on oxidation gives a monocarboxylic acid B. Then A is obtained by the action of Cl2 on ethyl alcohol. A is. Okay, so what are the informations? Let us first write down. A compound A has a molecular formula of CCl3OH. Okay, CCl3OH. It reduces Felling solution and on oxidation gives a monocarboxylic acid B. So this one on oxidation gives you monocarboxylic acid B. Now A is obtained by the action of Cl2 on ethyl alcohol. So A is obtained by the action of, you take ethyl alcohol and chlorine. Okay, so that is how A is obtained. Next, so what is then A? Okay, you have to find the structure of A. Okay, so now if you see here, okay, so now we'll see here that we have this one, B is, A on oxidation is giving you B, right, and which is a monocarboxylic acid. Monocarboxylic acid, right? So that means A must be an aldehyde group, right? So on treatment of this one with chlorine, we are getting an aldehyde group. So this is your structure is this one. Okay, here the formula C2. Okay, so CCl3CHO. This is nothing but your chloral. Okay, this compound is chloral. So correct answer for this question is option number A. Okay. So how this happens, you can see CH3CH2OH. Okay, now when you do chlorination, what happens, all the hydrogens are replaced with chlorine group. Okay, so what I'll get, CCl3C, you have here Cl, here you have Cl, and then here you have OH. Okay, after this there is reactions further to convert this one to CCl3CHO. Okay, correct answer is option number A. Next, compound A C5H10O forms phenyl hydrazone and gives negative tolerance test and iodoform test. Compound A on reduction gives N-pentane. The compound A is. Okay, so first of all it gives you a negative tolerance test and iodoform test, means it cannot be aldehydes, right? So we can remove this option. And if you see pentane 3-ONE will not give you iodoform test, we can remove this option. If you see pentane 2-ONE, that is pentane 2-ONE, this one, okay, it is saying it gives you negative tolerance test. So that is why we can eliminate option number, we can eliminate pentane 2-ONE, right? Because pentane 2-ONE will give you the test of iodoform test, right? But it is telling it gives negative iodoform test, so answer has to be pentane 3-ONE. Compound A on reduction gives N-pentane. So if you reduce this one, you will get N-pentane. Okay, next question. Iodoform test is not given by. So for iodoform test, what do we need? We need this compound, right? This group should be there. CH3CO group, or you can have CH3CHOH group. Right? Now if you see hexane 2-ONE, this one will give you, but if you see hexane 3-ONE, right? So this doesn't have this CH3 methyl ketone is not there, so this one will not show. Correct answer is option number B. Next, which of the following organic compound answers both iodoform test and Felling's test? So for Fehling test, first of all it should be an aldehyde, right? So we can remove this option, ketone option we can remove, right? Alcohols also we can remove, right? Ethanol, if you see, it reacts with iodoform test also because it has this one CH3CO group is present, right? And it is an aldehyde group, so it will give test for both. So correct answer is option number A here. Okay, next, for making distinction between 2-pentanone and 3-pentanone, the reagent is, so as I said you just now, 2-pentanone has methyl ketone, so we can use iodine with NaOH. Iodoform test will be applicable here. Next, which of the following compounds will undergo self-aldol condensation in the presence of cold dilute alkali? So for self-aldol condensation, what is required? Alpha hydrogen is required, right? So if you see here, no alpha hydrogen, here there is alpha hydrogen, here no alpha hydrogen. But this alpha hydrogen is attached to an sp2 carbon. So removing this H will be very difficult. If you remember the mechanism, what does happens here in the aldol condensation? Suppose I have this one, right, and if I treat it with dilute NaOH minus, it removes this alpha hydrogen to give me this structure, right? Now what happens, this H is attached to an sp2 carbon. So now this, in this question, what is there? CH2 double bond CH, C double bond OH, right? Now here what happens, OH minus is there, okay, this one will abstract this H, so I will get CH2 double bond C minus C double bond OH, right? So now what happens, this removal of this is very difficult because it is sp2 carbon. So that is why this one will also not show, this doesn't have. The correct answer for this question will be option number D, okay. Next, a compound A undergoes Cannizzaro reaction and B undergoes positive iodoform test, okay. So for Cannizzaro reaction, what is the condition? It should not have any alpha hydrogen. So if you see, acetaldehyde has alpha hydrogen, so this cannot be our answer. Here alpha hydrogen is present, this cannot be answer. Formaldehyde can be the answer. Propionaldehyde also has alpha carbon, so we cannot be the answer. Formaldehyde and 2-pentanone will give you iodoform test, so correct answer is option number C here, okay. Next, which of the following reagents cannot be used to distinguish between hexanol and 2-hexanone? Okay, so now you see this is aldehyde and this is ketone, right? So tolerance test we can use, aldehydes will show positive test. Now I2NaOH, if you see, I2NaOH hexane 2ONe will react, this one will not react, so you can use this one. Fehling solution, again aldehydes will react, ketones will not react. Br2CCl4 will not react with any of these two and we cannot use to distinguish this one. So correct answer here will be option number B, okay. Next, the reagent that can distinguish benzaldehyde and propionaldehyde. So you have benzaldehyde and propionaldehyde, right? Both are aldehydes and that can distinguish. So propion I2NaOH will not react with any of them. What is the structure of propionaldehyde? That is simple propanol, right? CH3, CH2, C double bond OH, right? This is propanol and you have benzaldehyde, right? So here we have, one second, okay, and here we have benzaldehyde, right? So I2NaOH will not react with any of them, so we cannot use this one. Fehling solution, okay, Fehling solution, I told you one very important thing, that aromatic aldehydes do not react whereas aliphatic aldehydes will react. So with Fehling solution this one will react but this one will not react, right? So this can be used. Tolerance test, again for tolerance test both will react. 2,4-dinitrophenol, again both will react. So correct answer is Fehling solution. Next, an aromatic compound X with molecular formula C9H10O gives the following chemical test. It forms 2,4-DNP derivative, reduces tolerance reagent, means it has to be an aldehyde group, undergoes Cannizzaro reaction, means no alpha hydrogen, okay. On vigorous oxidation, 1,2-benzene dicarboxylic acid is formed. So that is again shows that it is aldehyde group. Now 1,2 it is formed, that means, okay. So first of all we can see that the group has to be an aldehyde, so you can see all of them are aldehyde, but here is a ketone group, so we can eliminate this option first, okay. Next, all other options are same, only the positions are different, and here you see we need 1,2-benzene dicarboxylic acid, means they should be adjacent to each other, so the correct answer will be option number A, right? Okay. Next, we will go to some acids question now. which one of the following is the correct order of acidic strength? Okay, so first of all we have carboxylic acid, water and alcohol. So you have remembered that water is more acidic than alcohol except methanol. Okay, but here in general it is talking, so it is told about all the alcohols. So water will be more acidic and then ethane. So correct answer is option number C here. Okay. Next, which of the following will not undergo HBZ reaction? So for HBZ reaction, what is the condition? We need alpha hydrogen. So here it is there, this will undergo, this will also undergo. 2,2-dimethyl propionic acid, 2-methyl propionic acid. So structure of C, if I do propionic acid. So propionic acid, and here we have 2,2-dimethyl. So here you see there is no alpha hydrogen. If there is no alpha hydrogen, then there will be no HBZ reaction. So correct answer is option number C here. Next, which one of the following is the correct sequence of relative acidic strength? Again acidic strength, so you have electron withdrawing groups here. So you have fluorine, chlorine, bromine. Here you have chlorine, bromine, fluorine, bromine, chlorine, fluorine, chlorine, fluorine, bromine. So fluorine is more electronegative than chlorine, then bromine. So correct answer is option number A here. Next, among 2-chloropropanoic acid, 3-chloropropanoic acid, 2,2-dichloroacetic acid and propanoic acid, the Ka values will be. Okay, first let us note down these structures. We have 2-chloropropanoic acid. Okay, 2-chloropropanoic acid, 3-chloropropanoic acid. Okay, next we have 2,2-dichloroacetic acid. So we have 2,2-dichloroacetic acid. Then you have propanoic acid. Okay, so now you see Ka value. Here there is no electron withdrawing group, right? So that is why this one. Okay, first let us talk about here we have 2,2 electron withdrawing group. So this will be more acidic. So definitely 2,2-dichloroacetic acid will be more acidic, right? So we can eliminate this one and all other options are there. Next, if you see, we have okay, next here you have propanoic acid, here you have 3-chloropropanoic acid, and here you have 2-chloropropanoic acid. Now if you see second one is 3-chloropropanoic acid. Yeah, so here you see chlorine group is closer here, so here there will be better electron withdrawing group. So after that we will have 2-chloropropanoic acid, right? So the correct answer here will be 2-chloropropanoic acid. This one also you can remove, this one also you can remove. After that there is 3-chloro, and after last one is your propanoic acid. Okay, so correct answer is option number A. Next, when acetic acid is dissolved in benzene, its molecular mass. So this is also important question. So what happens when acetic acid is dissolved? Okay, CH3, and then you have C double bond O, OH, and then there is CH3. Now what happens, there is hydrogen bonding takes place. Okay, hydrogen bonding takes place and this molecule dimerizes. Okay, so these two molecules become one molecule, a dimer is formed. Okay, so that is why the molecular mass increases. Okay, next, the product of the following of the reaction. Okay, CH3COH P2O5. So here if you remember, this is P2O5 is your what is it, dehydrating agent, right? Dehydration takes place. So CH3, C double bond OH, and then you have CO, OH and CH3. So here what will happen, H2O will go and this oxygen will remain. So what I'll get, CH3, C double bond O, CO and then CH3. Okay, so one second, let me correct this one. So you have, I'll write like this, OH and, sorry, one second, we'll write it, OH is present, okay, and this H2O undergoes dehydration. So what we will get here, ethanoic anhydride. Okay, so correct answer is option number C. Next, benzoic acid gives benzene on being heated with X, and phenol gives benzene on being heated with Y. Okay, so what is X and Y? So it's telling benzoic acid. Benzoic acid gives benzene on being heated with X, and phenol, okay, phenol gives benzene on being heated with Y, right? So what will be X and Y? So X is your soda lime and Y is your zinc dust, right? So correct answer is option number D. Next, CH3COH LiLH4. Okay, so reaction says there. First, LiLH4 is a reducing agent and it reduces this one to alcohol. So I'll get CH3CH2OH, right? So this is your X. Next, if you treat it with copper at 300 degrees Celsius. So this is your what? Copper at 300 degree, that is dehydration of alcohols, and this is a primary alcohol, so it will give you aldehyde. So I'll get CH3COH, right? So this is Y. Next, if you treat it with dilute NaOH, so that is your again aldol condensation. So for aldol condensation we will get a aldol product. So correct answer is option number B. Next, consider the following reactions. Okay, here you can see this is an alcohol and this is an acid, right? And we are getting an esters. In the above formation reaction, ester formation takes place by. So I told you to remember this, that in alcohol OH bond breaks, but in carboxylic acid CO bond breaks, right? So this is A. So in A, what is happening? OH bond should break. Breaking of OH bond in A. Breaking of CO bond. So we can eliminate option B and D. So next there is OH bond in B. So there is no CO bond in B. So that is your CO bond in B and OH bond in A. Correct answer is option number C here. Okay. Next, last question. Which of the following is most acidic? Okay. So if you see, this is very important question. Okay. Now what happens? Generally you might think that these are all electron donating groups, so acidity will decrease, and that is why this can be the correct answer, because here there is no electron donating group. But here something that you should remember is ortho effect. Okay, what does ortho effect say? That if there is any substituent, okay, if there is any substituent at ortho position, whether it is electron withdrawing or electron donating, doesn't matter, the acidity increases. The acidity increases. Okay. So now what happens? That means whether it is donating or withdrawing, it doesn't matter. If there is any group present at ortho position, the acidity will increase. Okay. So correct answer is option number B. Now let us understand what is the reason for that. Now what happens? Because of this steric hindrance, okay, this COOH group goes out of the plane, okay. So now earlier what you used to do, if like how we used to do the resonating structures for benzene, okay, suppose this is there, okay. So what happens? When this goes out of the plane, there can be only two resonating structure, that is like this and like this, right? So these electrons undergo resonating and they cannot come back to the ring. So that is why the stability of conjugate base increases, and that is why ortho effect increases the acidity. Okay. So yes students, this was the complete revision of aldehydes, ketones and carboxylic acid. We have revised each and every reaction. So I want all of you to make notes from this and to make flow charts and to revise the reactions on a daily basis, so that you can remember and can easily apply them in the questions. Okay. So please make a list and flow charts for the reaction. And in the next class we are going to start amines chapter, and if you have any doubt in any of these concepts, please comment down. I'll definitely address it. And in the next, as I told you, in the next class we'll be starting with the amines, the last like one of the last organic chapter I can say. After that biomolecules is also there, but out of these 4 chapters, amines is the last chapter, right? So yes, stay tuned for the next class and please work hard and remember your target 60 out of 60 in KCET chemistry. Okay, do not forget to subscribe the channel and please join our WhatsApp channel also. Thank you and see you soon in the next class.